This is the optical lever experiment we have to do, and in this we have to find out the radii of curvature of this convex lens and the refractive index of the material of this lens. Optical lever, and for this optical lever, with the help of this we have to find out the radii of curvature and refractive index. This optical lever has four legs. This is called front leg and hind leg. These two are mid legs. These mid legs are longer than the front legs and hind legs. So while it rests on any plane surface, it rests on any three legs. So if it is resting like this, it is called resting on hind leg, and this is called resting on front leg. First, we have to measure the distance between the front leg and hind leg and mid legs. So take the impression on graph paper so that you can measure the distance between front leg and hind leg with the help of this graph. The points which are taken the impression from here to here, this is 1, 2, 3, 4.1, and the impression over here from here to here, this is 0.6, 7, 8, 9, 1.3. So this distance from here to here is 4.1 and this is 1.3. Between front leg and hind leg is 2a. Half of that is a. 4.1's half is 2.05, and the distance between central legs is 2b. It is 1.2. Half of that is 0.6. This is a and b. With the help of these values, we have to find out beta is equals to 2 a square minus b square upon a. On substituting these values, we get beta equal to this 3.748 for optical lever. Mount this plane surface, that is the glass surface, optically plane. On this glass surface, mount this convex lens, and on this convex lens, mount the optical lever. Now it is in position of resting on front leg, and confirm that while resting on hind leg, the leg should be on the lens. It should not fall down. This care you have to take. This is lamp and scale arrangement. This is called lamp. This is the scale, and this lamp is kept 1 meter away from the optical lever. The spot of this lamp on optical lever to get the reflected spot on the scale. This is the spot on the scale while resting on front leg. Touch this and adjust it resting on hind leg. On scale while resting on hind leg. So while resting on front leg and hind leg, both spots should be on the scale without disturbing the position of scale. So for that, first you have to adjust the position of the scale such that you will get the spot on front resting on front leg as well as resting on hind leg. Distance, record the distance L, which is distance between scale and optical lever. Here, this is the distance from this scale to the optical lever is capital L. We have to measure with the help of meter scale. Is first you have to take the reading for lens when optical lever is on surface S1 of convex lens. While resting on front leg, you have to take the reading, say R3, and read the scale on the scale. Here, the spot on the scale we are observing, and record the scale on the side of this scale is 0 to 50. That is your first reading. Resting on hind leg, this is the reading. With the help of this cross wire, you have to record the next reading, say R4. The difference between R3 and R4 gives D1, that is modulus of R4 and R3. You will get the difference between these two readings. Now change the surface of this lens and keep it like this by changing the another surface, and mount this optical lever resting on front leg and resting on hind leg. Again you have to take the reading for another surface. R5 for resting on front leg, R6 on resting on hind legs for another surface of convex lens, and difference between that two readings is D2. Now remove this lens and mount this optical lever only on plane surface, that is on mirror of this on this plane surface, and see that it is resting on front leg. While resting on front leg, see the spot on the scale. This is the spot when resting on front leg. Take the reading for the plane surface resting on front leg. Take the reading on this scale. These are the two readings when optical lever is on plane surface, that is on glass. R1 and R2. Difference of these two readings is D. By using this value of D, D1, D2 and value of L, by substituting in formula, we have to find out R. R1 is radii of curvature of that convex lens is equals to beta into L upon D1 minus D. On substituting the value, we get value of R1 is this. R2 is beta into L upon D2 minus D. By substituting the value, we get R2 is this. R1 and R2 are the radii of same lens, so it should be perfectly matching, differ by either 0.5 or 1 centimeter, not more than that. By autocollimation method, we have to find out the focal length of the lens. This is the lens, mirror, we have to keep over here. This is index pin, and see the image of that. Remove the parallax and measure the distance between lens and index pin, that is the focal length of the lens. Substitute this value of focal length of the lens in a formula of refractive index mu is equals to 1 plus 1 upon f into 1 upon r1 plus 1 upon r2, and we can find out the refractive index of the material of glass. And for this glass, its standard value is 1.5.